The Earth is bathed in an astonishing amount of solar power, about 173,000 terawatts constantly. That's more than 10,000 times the energy used by all of humanity at any given time. So, could we really power the entire world with just sunlight? To answer that, we first need to understand how solar panels work and explore the cutting-edge technologies that are turning this vision into reality. At the core of every solar panel are smaller units called solar cells, usually made from crystalline silicon, a semiconductor, and one of the most abundant elements on Earth. In each cell, thin wafers of silicon are sandwiched between conductive layers. The silicon atoms hold their electrons in tightly bonded positions, which means no electricity can flow yet. But here's the trick. Solar cells use two types of silicon. One side, called N-type, is rich in electrons. The other, P-type, has empty spaces, or holes, for electrons. Where these two layers meet at the p-n junction, built-in electric field forms. This field plays a crucial role in directing how electricity flows once sunlight hits the cell. Sunlight is made up of photons, tiny energy packets shooting from the sun. When a photon hits a solar cell with enough energy, it knocks an electron loose from the silicon. That freed up electron, along with the resulting hole, becomes mobile. Because of the electric field, the electron moves toward the N side and the hole toward the P side. The moving electrons are collected by ultra-thin metal fingers on the cell's surface, creating an electrical current. These electrons travel through a circuit powering devices or homes, before returning via the conductive layer on the back of the panel. Each solar cell only produces about half a volt, but when wired together in panels and arrays, they can generate significant power. 12 solar cells can charge a phone, and large installations can power entire cities. And since only electrons move, there's no wear and tear. That's why many solar panels last 25 years or more with minimal maintenance. So what's stopping a solar-powered world? Some of it comes down to geography and weather. Not every place gets consistent sun. We also need to solve the challenge of storing solar energy for cloudy days and nighttime. But technology is catching up fast. Modern batteries like lithium iron phosphate and emerging solid-state batteries are becoming more efficient and longer-lasting. Huge systems like Tesla's Megapack can already store power for entire communities. Then there's the rise of perovskite solar cells, a new material that promises even higher efficiency and lower costs than traditional silicon. Some hybrid designs already surpass 46% efficiency, which is remarkable compared to the 15–20 of most commercial panels today. We're also seeing amazing innovations. Bifacial panels that absorb sunlight from both sides, flexible solar sheets that can be rolled onto surface windows that generate energy while letting light, and even space-based solar farms, which could beam energy to Earth around the clock. So yes, it is possible to power the planet with solar energy using today's technology. We'd need investment, political will, and infrastructure. Estimates say we'd need tens to hundreds of thousands of square miles of panels, yet the Sahara Desert alone spans over 3 million square miles. And in many parts of the world, especially in developing regions, solar is already the best option. Portable solar kits, off-grid microgrids, and solar-powered water pumps are changing lives where traditional electricity isn't available. In places like Finland or Seattle, a full switch to solar may still be years away, but with floating solar farms, self-cleaning panels, and increasing efficiency, solar power is moving from possibility to inevitability. The sun gives us 173,000 terawatts of power every second. All we have to do is keep finding smarter ways to catch it.